The Arctic, an unfathomably inhospitable frontier of barren snow, ice, and sub-zero temperatures. Yet it remains one of the most alluring prospects into the foreseeable future for many countries. But with seemingly little to offer, just what is it that makes the Arctic such an attractive commodity is not what appears on the surface. An estimated 22% of the Earth's oil and gas reserves remains deep beneath the ice and ocean, locked under the Arctic seabed. And what's more, with rapidly melting ice due to the effects of global warming, quicker and more efficient trade routes over the North Pole have begun to appear. With countries such as Russia and Canada racing to contest for sovereignty, the message today could not be any clearer. Conquer the Arctic and reap the economic benefits. However, the multitude of problems associated with exploration and development of the Arctic pose a unique challenge, requiring technological innovation on an unprecedented level to contend with the extreme conditions. Mechanical engineering provides many solutions to these issues, with exciting developments in the field that show promise to build a better future. I'm going to talk about how mechanical engineering has made contributions to exploration and development of the Arctic through innovative design of icebreaker ships. Ever since the introduction of icebreaker ships at the turn of the 20th century, not much has changed in their design. The same fundamental principle of operation remains the same. The ship pushes itself up onto the ice ahead and crushes it from above with the weight of the vessel. These mammoth ships are used to clear pathways for smaller boats, allowing for transportation in polar waters. Traditionally, such vessels only operate going forwards or backwards, but recently a radical new approach to icebreaking has been realized, thanks to some marvelous mechanical engineering. This is Baltica, the world's first oblique icebreaker. Equipped with an asymmetric hull, she is capable of operating with a large angle of attack, which allows for an unusually wide channel to be opened with a relatively small footprint ship. 3 engines on board provide 9 megawatts of power to the 3 azimuth thrusters, which allow for quick maneuverability and steering adjustments with 360 degrees of rotational freedom. The ship also uses a unique pump system to dynamically change its center of gravity by cleverly distributing liquid fuel and bilge water between tanks contained in the ship's hull. These innovations allow for such a state-of-the-art vessel to exist, creating opportunities for large merchant vessels to move freely in the Arctic. Baltica is the first of a new generation of vessels that will expedite trade and intercontinental shipping, all made possible by mechanical engineering. Another challenge associated with the use of icebreakers is the massive amount of power needed to successfully break through ice that can be up to 2 meters thick in places. Typical diesel-based icebreakers consume ridiculous amounts of fuel every day, requiring frequent refueling stops and producing large amounts of greenhouse gases. Instead of using conventional fossil fuel-based ships, mechanical engineers have helped to design nuclear-powered icebreakers, which take advantage of the extremely high energy density of uranium. For example, this state-of-the-art Russian icebreaker, 50 Years of Victory, uses dual fission reactors to generate 55.2 megawatts of energy for 74,000 horsepower of thrust, while using only half a kilogram of uranium a day. For reference, an equivalent vessel powered by diesel would consume over 90.7 metric tons of fuel in the same time span. Now, these ships powered by cleaner energy are able to go on voyages for much longer durations of time, since they no longer need to return to a port, maximizing efficiency. By design of nuclear-based power systems, mechanical engineering has created potential to decrease the environmental impact of exploration on the delicate Arctic ecosystem, which many people living in the north still rely upon. With the exciting prospects of Arctic exploration and development, icebreaker ships remain an integral part of such endeavors well into the foreseeable future. Development of more efficient oblique icebreakers and cleaner energy generation are just 2 examples of many of the ingenuity and innovation contributed by the field of mechanical engineering.